Witam i dziękuję bardzo. You know my Polish, huh? But witam na mojej sesji. Today we want to talk about daily indexing performance problems, but we mean problems where indexes cannot help. So this is a typical scenario here that you have maybe installed perfectly written indexes and you're wondering why it doesn't work. I have lots of demos here. You know, the people who know me, you know that I love to make demos, and this is basic. This is pure demos. So if you want to replay this, then what you can do, you can download the big ERP demo database, which is 17 gigs, or you can download the smaller one, which is 450 megabytes. I don't like to work with small, tiny number of rows. That's boring. So this a little bit about me. Forget about the commercial thing here on the left side. Just only concentrate on my email address. So whenever you think, oh my goodness, it was too fast what he did, then just drop me an email and I promise you to answer your question as fast as possible. So this is our agenda. What I want to demonstrate to you is that how you can optimize objects, whether you have set an index or not. And I have 5 demos here. So you see that the last 3 are light gray. Basically, this session is for 75 up to 90 minutes. But in the scripts, you can have all these demos too. I want to talk about partition views, searchable queries. Correct data types for predicates is a very common issue, what I see very often in my when I get called to customers. Simplification by using foreign key constraints, and last but not least, the side effect of wrong collations. What I do here is I want to explain to you, these are all, by the way, real world scenarios, but they are very strong simplified, which means I want you to follow the problems, but not to see the whole scenario. So here comes the first one. Maybe the older of us, so I'm over 50, I can tell you about this, working with SQL Server before 2016. And with SQL Server 2016, especially with the Service Pack 1, you had the great opportunity to use partitioning in your database. Before SQL 2016, it was a feature which was only available in enterprise editions. So what did the people do? The people tried to invent other techniques to do that. And one of this is that you have partition views. This scenario, what I want to show you in this demo, excuse me, is a company which did a separation of the orders for every single year. So for every year, they created a new table. Then the developer team came across and said, okay, it's okay what you do, but we want to have just only one access layer where all these information get queried from. So what they did was they created a so-called partition view to consolidate both all data sources to one access object for the users. So follow me to the demo. This is a funny part. So I hope that you all can see my Visual Studio, my management studio. And what I do now is a very primitive thing. I have my customer orders. Come on. You know, my CPU is up and running. So what I'm doing here is I create a demo database. And in this demo database, I now prepare the problematic scenario. Therefore, I'm going through a table with 3 million rows. And now I extract for every single year the orders and put them into separate tables. It takes a little bit, but hopefully my machine is fast enough. And if I look to the tables, you can see here what the system is doing. So for every single year, I get a separate table. And that was the typical behavior with standard edition before 2016. So now I'm in the role of the developer and I create a brilliant view. So my view is called all orders because I want to get them all together again. And therefore, I create a view where I have every single table touched with the union all, and so I gather all of them together. So here it is. And then they implemented it in the production system. Unfortunately, the customer was not so happy with that because the biggest problem was the performance. So I now set the statistics IO and time on that you can see how long this query will take for a number of rows, which is around 6,000. So what this query will do is very easy. I say, please give me all the orders from the January 2014. And when I run this query, and it takes a while. So the reason is very simple. We have 5,000 rows. The reason is very easy to explain. I do not have any index on the system. So you see here that SQL Server is using all my cores. I have just only 4. And it's scanning the whole table. It's going through all the tables. And the execution plan proves it by evidence. And you can see here that we now touch every single table. So now the developers were sitting together and saying, oh my goodness, what shall I do? And someone came to the idea and said, create an index. Okay, let's do that. And we create an index. And I do it very easy here. In partitioning, you have a so-called partition key. And this partition key I don't have here because we don't use partitioning. But what I will do is here, just only for simplification, I create or I make the tables clustered based on the order date. This is untypical here, basically, because it's an ERP system. But in this case, just only for the demos, I do that this way. Okay, so now they create on every single table a clustered index on the order date. And they are sitting there drinking their coffee and say, yeah, everything will be fine now. And yeah, let's see what happens. We have a clustered index on the order date. And my expectation is now that SQL Server knows exactly where the rows are. And I run this query. It is faster, by the way. Yes, it is way faster. But have a look to the messages. What I see here is, oh my goodness, it's less. We have less I/O because of the natural of the cluster key. But I'm touching every single table here. So now think what will happen if you access a table where someone else is doing an update or an insert in, then your query gets blocked. I will show it in a different scenario. So the execution plan demonstrated to me too. I can see here that I now touch again every single table, which is not the idea behind a partition view. So what can we do? The development team at that site said, well, that's fast enough, enjoy. So, but then they got the problems with the blocking and locking, and they asked me whether I can have an idea what to do. And the only thing, what you need to be aware is what information would you need as let's say as an executor from that query that you can definitely say, I know that in the table A, B, C, D, there will be no data for me. And you all know this whenever you have developed some tables, and I think most of you have used constraints. So constraints, let's say you get defaults. The default is a constraint, not null is a constraint. And all these constraints can be used by the query optimizer to perform better query improvements. And the information, what we need here is, we need to tell the query optimizer, hey, come on, in this table, you will only find the orders from 2014. And with what will you do that? With a check constraint. And that's what I'm doing here. So also we have an index on our table and we are feeling pretty confident that everything is fine. We have some lags here. So here is, I go in a loop with this, with an with an SP execute SQL. And what I'm doing is very easy. Here, I start with the year 2000, and I end up with 2019. And the only thing what I'm doing is I say add the 2000 and here the 2001, that I have now the time limit or the date limit of the data. I run this. It takes not very much time. And now I run exactly the same query again and see what happens. The system is fast. It was fast before too, but click. Look to this. We now just only have the 2014 table, and your execution plan is looking so beautiful because we are accessing just only one table, and SQL Server detected by the check constraint. We made it a little bit easier for the query optimizer. And what will happen if you access two tables? Well, I'm doing this. Now I'm accessing 2013 and 14 and see what SQL Server is doing. SQL Server know that it could only be these two tables and access the two tables. So you save lots of IOs. It could be not only, in my case, it was 20 tables, but what will it be if you have 100 tables? And the second thing, what you will eliminate here is when you don't have access to tables you don't need, then for what problem or for what risk do you have for a blocking scenario if someone is editing the 2019 while you're looking in 2013? Yeah, back to the future. So this is the first thing. When you're working with partition views, make sure that you're using check constraints on the attributes of each table, which you want to partition it. And that's the easiest way. If you have Enterprise Edition or you have SQL Server 2016, then yeah, enjoy. Then you can use the Standard Edition for using a partitioning feature. Is null and searchable predicates. Oh my goodness, yeah. And this is something what I see, to be honest, very, very often. And here is the scenario. A developer has a production table, and what he did then was he took the production table, he just only looked to the attributes and the data types, and then he created his own test table, migrated all the data from the production into the test table, and then he was checking it, where can we do some perfect indexes on it? And that's what he was doing. He was implementing an index, and then he deployed it to the production. In the meaning, hey, he's the superstar of the department. Unfortunately, the customer complained about the performance. And what was going on here? Let me show you the work or the process, what happened here. I create again my demo database, and then I create my production table. You see it here at the extension prod, and please have a look to the invoice number. The invoice number in the production table is nullable. So we create this. By the way, I forgot to mention that the query came from an application from a vendor. So now I'm in the role of the developer. I saw this table and said, oh yeah, I need to check it. Where are all the problems? And then I create my own table, customer orders test. And there is one tiny little thing what I had completely overlooked for. The invoice number in the original table was nullable, but not in my test table. That's it. And now I fill my my production table. Takes a little bit because it's 3 million rows. So we get all the orders now from my demo data, from my customer orders database, and we push it into the production system. Then I do a few things to change a few data. But then I take all these data, which I have in my product system, and I write them into my test system. So that will take approximately 30 to 40 seconds. In the meantime, I will check now, do we have any differences? Because you might say, oh, come on, maybe Uwe is doing some dirty tricks here. I'm not doing it. You see here my production, 3 million rows. And by the way, this is a little typo. So now it's okay. The production system had 3 million rows and the test system had 3 million rows. And every good developer knows whenever you do some testings, set statistics, I/O and time on to see how much I/O you produce and to see how much CPU you burn. So here it is. Here is the query. It might be that a few of you will say, oh my goodness, I know Searchable, there is a function in it, the isNull function with the invoice number. And this isNull is truly, it could be a problem for searchability, search argumentable. So we run this query with the execution plan, with the existing execution plan, and because I don't have any indexes on it, you will see it makes a full table scan or a clustered index scan. Okay, so we now see that we need an index on the invoice number. Okay, we do so. Here we are. I create my non-clustered index on the test environment. And afterwards, when this is implemented, I run the query again. So here is my query. We have 1,000 rows. We look into the execution plan and we say, yeah, perfect. The parallelism is gone. The SQL Server is not scanning the table. Now we seek for a value and have a closer look to the seek predicate. When you compare it to the where clause in the original query, you won't see an isNull. And the reason for that is nearby exactly the same as with the previous example with the partitioning. When you help the query optimizer for its decision, and that's what we did, yeah, then it's quite easy for the query optimizer to generate good plans. In my test table, the invoice number was not allowed to be null. SQL Server knows that and say, hey, come on, he's using an isNull function, stupid guy. We remove this. And SQL Server could automatically make a non-searchable query a searchable query. So the developer saw everything was fine, and then he decided to put this index in the production environment. He raised a ticket, everything was fine, put the script to the change request. On a weekend, it's got implemented, and the development team thought, okay, everything is good now. Then the query comes into production. And here we have a problem, because what we see here is, again, a complicated plan. Everything is going parallel. What SQL Server is doing here is SQL Server is using the isNull as a pushdown predicate. You don't see a seek predicate like, hey, the invoice number is like this. It cannot be possible, but SQL Server is now checking every single row in the index, whether it is null or not. And the reason is, as you have seen when we started with the demo, that the invoice number in the production system was allowed to be nullable. And therefore, SQL Server could not be sure that they don't have that they only have filled values in this column, and that's the reason why we use this isNull. So now the developers were thinking, what can we do about this? An index doesn't help. The only thing what they can do is they need to rewrite the query. Let's do it. I run this query and excuse me, I know I can skip this here. So here is the solution. If you have an isNull functionality in your predicate, it is exactly the same as an OR statement. So if you divide the isNull to the statement or the column is this value or this value, and that's what isNull indicates, then SQL Server can use the index. I do this. Look to the query execution plan. It looks a little bit complicated, but I promise it isn't. What SQL Server here is doing is very easy to explain. take the first condition, the second condition, and put them together in a separate internal table with 2 rows. One of the rows is representing the null, and one of the rows is representing the substitute. Now SQL Server can come with both values, and now we can use an index seek, because now we are looking especially for these computed attributes at values. Then we can come to the key lookup easily, because we only have the invoice number in our index, and then we push out the data to the client. Second possible solution. This one is when I read blogs from other experts, and I see mostly, or when I talk to developers, most of the developers sometimes say, oh, no, I don't like or is bad. Say, okay, you don't have to use it. Give me a substitute for an or. And one of the substitutes you can have is a union. Union all is the same, exactly the same. Here you separate for every single or condition, you put it in a separate union select statement. When I run this query, you will see it looks more friendly, because here you can see that we have, here's the first one. We say, give me all the rows where is nothing in the invoice number. And you see that it's used as a seek predicate. Perfect. We come with these 0 rows, but then we come with the second stream. And the second stream is for give me all where the invoice number is equal to the value for the what we have mentioned in the is not function. The union statements, I love that. So there is one thumb of how do you say? Thumb of rule. As more you write, as better the query is. And but many people don't like it, because let's say if you want to have another column in the output, then you need it here, and then you go to the next union and put it there, and so on and so on. Think about, you have 10 different ors. It might be this or this or this or this, yeah. And then you need to add this column to all the separate select statements. There is a better statement, a better way to do that. Put it in an in clause. Here we have the same query. I say, give me the data I want from my table, where the invoice number is in, and then I make this select statement inside the subquery. And that works the same way. And so I will have to admit, it's a cool product, SQL Server. I love this, the way how SQL Server handles this. Lesson learned with that is, don't use is null as a search condition for nullable columns. By the way, if you know that there will be no nullable values in this column, why won't you use this? Yeah, you don't have to. Instead of is null, try to use an or statement or a union all statement, or take a subquery where you have all the union statements inside this subquery. But the best practice is to have no attributes which are allowed to be nulls. Better is to have, let's say, a color where you say, no, it is not allowed to be null, but if someone doesn't want to have a value in, then I put a substitute in. It's better for indexing, as you have seen here. Good. Oh, yeah. Oh, that was a funny thing. Correct data types for predicates. I have seen very, very much developers coming more from the middleware or from the front end development, and they love to work with entity framework, code first, all these new technologies, which I never have touched in my life. But here comes the good thing. When you're working with entity framework or with Hibernate from Java, something like that, the good thing is that the developer does not need to consider databases. That's what the language implies. Say, come on, use my great tool. I have entity framework, and you can do everything with that. It's so easy. The good thing for me is, as long as people are using these kind of frameworks and not properly, I have enough to do. Yeah. So here comes the problem. A new application has been purchased and the application suffers from performance when searching for customer numbers. The attribute ID is indexed, but the execution plan showed an index scan instead of an index seek. What happened here? We built this, yes, I want to save it. We built this. This is the correct data types. And again, I create my demo database, and here is my customers table. And please notice here the following. You see that the ID is completely untypically a character field. It's not a numeric one. By the way, this comes from an original software. And I asked the vendor, I said, why are you using for the ID a character and not an integer or a big int? And they told me, well, the numbering depends all on the requirements of the customers. So they have, I believe this, they say they have lots of customers who have their own numbering. They have a character before and then they number it and these kind of stuff. And that's the freedom they wanted to give to the customers. And that's the reason why they put it in a character. I said, okay, fine. Then we ran some examination on it. And the first thing what I'm doing is I now put around, it's 75,000 rows now in my customers table. Let us see how many data pages this table allocates now. We have a clustered index, and what you can see here is that we have pure data pages, 5,770. For 75,000 rows, it is okay. It's not so big. Here comes the query. And that was, come on, that was one of the problems. This special customer where I was invited to was not using some special characters or alphanumeric characters. They were just only going straight forward, say, give the ID a 1, a 2, a 3, and so on. And here is the query. And I think, oh, one row, incredible fast. If I look to the messages, I can see here that it was fast because of the output, but we were scanning through the whole table because we touched every single data page. Second thing, the elapsed time with 74 milliseconds, which is, by the way, absolutely great. It's fine so far, but have a look and compare the consumed CPU time with the elapsed time. So this query was, while it was running, permanently burning CPU. And what was the reason? I want to show you the execution plan, and you will see here that SQL Server is using a clustered index scan. Also, you have a clustered index on it, but if I look to the operator, have a look to the predicate again. For all people who are not so familiar with execution plans, just one important note. Whenever you feel there is something suspicious going on in your query, move over to the operator and first look should be, is it a predicate or is it a seek predicate? Whenever you have a predicate, it might be expensive. And you can see here exactly what happened. What SQL Server was doing, first of all, we couldn't use the index for an optimized seek. Second, SQL Server made a convert implicit to this attribute, what we were looking for a value. And you see here that SQL Server did not touch the search predicate, but SQL Server touched the column. And that is the problem here. Because now SQL Server was going through all 75,000 rows, converting the ID to a numeric value, and then the result has been compared to the search argument. Oh my goodness. And that is the problem here, or that is the time-consuming problem here. Another topic to new developers of SQL Server, if you want to make push-down predicates visible, you can use, but only in development. Please do not do this in a production system, nor do it in a query what you run in production. The query trace on 9130 gives you the possibility to make push-down predicates visible. Here now you see the difference. Now I don't have only the cluster index scanning going over to the select. No, I have the filter in it. And here you can see that SQL Server is transferring 75,000 rows to the filter operator and asking, hey, are you an integer with the value 10,785? No, and then you go, and so on, and so on. And then they leave the values which fit best. So here is again an exclamation mark that say, come on, you're using and convert implicit. It might be not a good idea. Have a look to your execution plan and see what is going wrong in it. So what SQL Server is doing is, and that's what I want to show with the last query here, is the conversion is on the wrong side. We made a good working index due to the fact that we used the wrong data type for the search predicate, non-searchable. And that's something we don't want to do. How is it the right way? Well, here, this is the right way. Use the correct data type. Then it will work like a charm. Now I have an index seek. You see the seek predicate, and we have a fantastic IO. From 5,000 down to 3. That's perfect. And look to the execution time. That is what you as a developer wants to see. Yeah? And where does this problem come from? This problem was coming from the, in this case, it was an hibernate, and they took the wrong data type for the query. That can happen. If you can't change it, then go to the vendor and ask the vendor. Here is a special case. You can see here that I now take an nvarchar, which is ANSI code, which is different from ASCII. And when I run this query, it goes fast, but SQL Server, and that is a brilliant step what SQL Server is doing. This here is normally non-searchable for the column, but SQL Server is changing the data type by using this compute scalar. So it makes the nvarchar an ASCII character, and then we can use the index again. This can only work if you're in the same, let me say, set of data types. So let's say if you have string data types, varchar, nvarchar, char, nchar, and so on, SQL Server can handle it by itself. But if you're leaving these set of data types and go to another one, to the numeric side, then you have the result I have shown you before. Good so far. And this is my, let me see what's the time. Oh, perfect. Cool. Correct data types for predicates. Make sure that the correct data types will be used as a predicate. If you're not sure whether the correct data type is used, then you can check the execution plan for residual predicates. Or what you can do, but only do that in your development environment, only for testing, activate the trace flag 9130, and then you can see the expensive filter or push down operations in your execution plan. And that is a brilliant way how to investigate these issues. So also, we had a very good working index. SQL Server was not possible to use it, just only for this tiny little problem. Solved. Money earned. We go to the next one. And this is truly a very interesting thing. And by the way, I have to say, when I'm in projects, I'm currently in a big project here in a German company, and they hired me only for database development. I do not have to do anything with middleware or with web interface. My only responsibility is the database. Many projects don't do this. Many projects don't have the time and the money for doing that. And not many, but what developers sometimes forget about is that SQL Server is a RDBMS, relational database system. And for a relational database system, there are two key components which are mandatory for integrity. The first one is every table for normal form needs to have a primary key for its uniqueness, for making sure that you have a unique identified record. The second one, what is required in an RDBMS system is that we have a relation in between the tables called foreign key relations. A foreign key makes sure that you do not have rows in an order table, for example, this is what I want to show you here, that you do not have an order with a customer ID where you don't have the customer for. And to prevent this, you're using foreign keys. But what many developers do not know is that SQL Server can use this brilliant thing for integrity of data for optimizing queries. And this is what I want to show you here. We have a scenario where we have three tables. The customers who placed the orders itself, and the employees who was selling the stuff. Then there has been created a view to access these information from all affected tables. Second, to be honest, second big failure from my point of view. I see lots of views implemented in SQL Server where they have joins over 4, 5, 6 tables. You don't see anything from the columns, but only tables. Left join, right join, anything. It feels like dancing. Left join, and right, and all these kind of stuff. And the problem here is that the developers want to cover nearby everything with this one query. This is my golden data set. And you say, whenever you need data, take this view, and I have everything in. Yeah, and when you use this view, you're wondering about a bad performance. And here it was exactly the same problem. Sometimes the view was running, let's say, incredible fast, but sometimes it was degrading. The performance degraded, and it was a truly nightmare. And we have three big problems here to solve. What's going on here? This is our last demo, and then we can do Q&A for these funny things here. Number 50. I have to go outside of this. Here we are. So I create my demo database again and put my data, which I want to work with, into, I transfer it into my demo database. Run. Okay. And now we are perfect database developers. What we want to do now is we want to make sure that the data are unique. So therefore we implement primary keys on all three tables. The customers has its primary key on the ID, the same as the customer orders, and the same as the employees. And here is my view, my one and only golden view, which covers nearby everything. I'm doing here a simple join, giving the customer ID and the order date, and make a few calculations with the order date that people can run queries again, the year, the month, all this kind of stuff. And then I have the employee ID and the employee last and first name, just only for the demo purposes. And you can see here that I'm using an inner join. So equal connection between all the tables here. This is my query. And again, we are all good developers. we are using statistics, I/O, and time on, because we want to see how much I/O do we do and how much CPU time we are consuming. This is the query which is fired by a report from reporting services. Give me the customer name, and then please give me the number of orders this customer have. And what I'm looking for is just only for customers where the ID is smaller or equal to 100. Run, run, run. We have 100 rows. We see here that we have 44, and so on, around about 40 orders per every customer. We go into the I/O, and here you see that we have a perfect seek on the employees. See here, the logical reads is only 4. The customer orders could be better. And the customers is nearby perfect because we have 100 for 100 customers. We had 336 I/Os, which means I will see later on in the execution plan that it was going with a nested loop into it. The problem here is the customer orders. The customer orders seems to be because we see a scan count of 5. Parallel. Yeah? And the logical reads is the full table. So what I can see from here is my employees looking good and my customers are looking good, but the biggest problem is my customer orders. And what I don't like is this work table, and another work table, 3 work table access. So that means TempDB access. Let's go to the execution plan. And the execution plan looks a little bit like a nightmare. Let me show it better in Century 1. It seems to be better because I have more place there. So in the meantime, brilliant, here it comes. I love this Century 1 Plan Explorer. It's way better to see information. So I zoom it. So here is my plan. So you see that we go through the employees. The reason is very simple. We do not have a predicate on the employees. Very easy. We come with 150. The big point here is that SQL Server was using all of them because we're going with a hash match operator into the clustered index. Ooh, there is my expensive operation. You see here that with the cluster index scan operation, there were 4,000 rows coming back, and then they were merged with the employees, and then we made the aggregation, the count, that we get the customer ID, and then we go for every single customer ID with an index seek in the customers. First of all, I would say, okay, accept the customer orders, but everything looks good so far from the employees and from the customers. We, as developers, have seen the problem, and we've decided to add a non-clustered index on the customer orders on the customer ID. Because when we do that, that's way easier than for us to merge. Another big issue is, or a great benefit is, you see here my count big. The count big here is because is the aggregation, and maybe we have luck and we get a perfect plan by counting only the customer ID. So I create this index because the developer saw what's going on, and now he implemented an index and thought everything is good. Is it better now? That's the big question. We will do this. And so normally, that's the reason why I really miss on-prem sessions. Normally, I would stand in front of you and would ask you, hey, what do you think? Is that good now? And we all would say, yay, that looks perfect. Why is it perfect? Well, first thing, we do not have any parallelism in our execution plan. Second thing, look to this. It looks so cool. We have an employees is okay because for the 150 rows, it's a tiny little table only. But look to this. SQL Server made a perfect customer orders index seek. And we can see here, well, look for the customers which are smaller than 100. Then it goes back into the customer orders table, because what we need to have is, we need the, where is it, output list, the employee ID. The employee ID is needed because we want to merge it here. Okay, think about this. Then we come back with around, where is it? This is the aggregation. Yeah, 4,000 rows. Then we put them all together for every customer, one number of orders. And here we're coming back with 100 rows. And now it's easy. For every single row, go into the customers and grab the data and then make a sort, that's an order by, and then push it out. The developers see, that is okay. We gave that to production, implemented it, and we thought no more problems. But then the problem occurs. What I'm doing here is the following. Now, while someone is running a process, an update process, come on, here we go for it, here. I run now this update here. No, come here. So very easy. Update my employees, said last name Ricken, first name Uwe, where ID is equal 10. That must be an incredible fast update. Let's see what SQL Server will do. Oh, that looks cool. Yeah, it's a clustered index update. Super. Okay, what we do is we run this. And now think that it's not only just one row. It could be that you have a long running transaction here. The problem is, you will see it here. This is a view I have implemented in my master database because I use it very often to investigate loggings. And you can see here that now my object employees is locked. It's an intent exclusive log. But the point is that the key log, because it's a clustered index, exclusive log is now on the employees. In the meantime, while we are doing our long-running transaction, there is someone who wants to run this query. And you remember, it was fast, it was okay, it was, I would say, perfectly designed by the indexing. Oh, it's not coming back. Hey, what we are looking for is, see that we say, hey, come on, we only want to have the name of the customer's table. Then we want to have the number of orders, customer orders. Why the hell is this one stopping here? Why can it not run? Let's have a look to the logs. You know that this transaction is open anyway. And when you see this one here, you see what the problem is. You see here two different sessions. The first session is the number, let me see this here, 61. 61 is the one which is running the select statement. So we take care of this one. And you see here that the 61 is having an intent share log on the customers, orders, employees, all three tables. So SQL Server is accessing all three tables, although we only need two of them. And then we go to the next one, which is the page. And here is the disaster. You can see here, this is working, by the way, because we have indexes. We are sharing this resource. One wants to write in this page, and one wants to read from this page. Unfortunately, that is the conflict. So this is the key. This is this is the, excuse me, it's not Corona, just only smoking. This is my resource. This is the employee with the ID number 10. And here is the conflict. While the update is using an X lock, exclusive lock, this one has to wait. And you see here perfectly that the number 58 is blocking the select statement because it wants to set a shared lock on it. What can we do? I would say a good DBA knows immediately what to do. A good DBA is running this. Okay, but I do this, have a look to this executing and see immediately, bang, now when I kill this, my query is running. And when now someone is calling from the reporting department, say, what's going on here? What will you say? You can say, well, yeah, there was someone who's doing an update on a table and we did not know how long it was taking and we did not know how the application is working. The only thing what you need to do is when you see these problems, very easy, the first question you have to answer is, why was SQL Server accessing all three tables? This is the first question here. The reason is when I look to this view, I can see here that this view is taking all three objects. That might be an explanation for it that we run into these problems. But as a DBA or a developer, do not give up here and say, this is the query. The problem is not the query. The problem is the implementation of the integrity in your system. Because you remember we created these tables. We created a primary key. Nearby every table I see has a primary key. And then at that point, development stops. For whatever reason, it stopped here. So think about what we did with the isNull. With isNull, we helped the query optimizer to make sure that you don't need to use an isNull function, which you are using accidentally in your code, when SQL Server know that there could be no empty entries in the table. Think about partitioning what we did. The first example, the first demo. You remember that I put a constraint on the date to tell SQL Server what data SQL Server will find in each table? And that is exactly the same what we should do here. By the way, with every OLTP system, OLTP database. Data warehousing is a completely different story, but OLTP systems should have referential integrity in it. So SQL Server is using these three tables because SQL Server do not know or cannot be sure that it don't have to touch the employees table, whether we are using it as an output or not. To make it proved by SQL Server, put in a foreign key constraint. And that's what I'm doing here. I now add a foreign key constraint on the customer orders and reference the customers table. Number one, done. That's quite fast, very easy. Now it had checked the values. And I do the same with the employees. Exactly the same. I say, take the employee ID from my customer orders and make sure that there will be only values which are existing in the employee table. Now, I run this query again. It's the same performance, I would say. But on the other hand, what I'm doing is I run again this. I make an update. Yeah, this is okay. Disconnected, go. So, and now when I run this query again, you remember it did stop, but now it's working. We do not get any stoppings here. And the reason is very easy. If I look into the execution plan, look to this, this is a brilliant plan. What we do here is we have two big issues here solved. I roll back that I know that I don't have open transactions when we're finished here. We have two perfect issues here. Maybe the one maybe a few of you have overseen that with the customer orders, in the first query, we needed to do a key lookup to get the employee ID. I hope that you remember this. We needed the employee ID in the output list. For what reason? Yeah, we needed it for the join to the employee's ID. Now we can use the smallest index I have in my customer orders because we just only do a count on it. And that means that we take here my newly implemented index on the customer ID. Come on, show it to the audience. I'm not so shy. So, and you can see that we're doing a seek predicate. Brilliant. And look to the output. The output is just only the customer ID. And there we can do an aggregation on it. And that's so easy. Here is my aggregation. And due to the fact that the index, the customer index, the customer ID index is ordered, we can use a merge join instead of a hash join. A hash join requires memory. A merge join can pass through the data without allocating memory. The only memory we are using is here for the sort operation. And this one is 1 meg, I think. Yeah, 1 megabyte. And so you can see how also, although you implemented indexes, sometimes indexes do not help. So this was the last demo here. I will upload, or I will send to the organizers this slide deck and the demo. In the demo, there is the link for the customer databases where you can play around with this. For you as an as a developer, I can strongly recommend to you, play around with it. You will love it. And when you see the improvements, this will be a perfect experience for you, to be honest. So these are the ones I have not covered here, but I can really recommend to you, play with that. So we have, oh my goodness, only 3 more minutes. But now I'm open for questions if someone has some questions here. You don't have to be so shy. Maybe we meet in the lobby. Sorry, yeah. Oh, COVID, yeah, I forgot. Yeah. So in this case, let me see if there's something in the chat. Can I see this? F&A. No open questions. Well, that does mean that all my explanations were so easy to understand, or maybe all the 150 people here in this session were so well experienced that they said, oh, come on, it's just before lunch. I want to have a coffee and just only have some enjoyable session. I thank you so much for being my attendees in my session. I hope you enjoyed it so far. And I would say, do widzenia, and we see us hopefully the next year in Poland. Bye-bye.
Sorry, Uwe, we have some questions over there.
Oh, yeah, true. Okay.
Yeah, one on the chat and one on the QA already.
Oh, I see it here. Yeah. Using count versus count big. You mean this one, yeah?
Yes.
Okay, yes. Oh, that's a good question. Yeah, I'm using it very often here. Yes. Yeah. So to the people who doesn't see that, I'm using count big here, and the count big is very. Let me do it this way. Let me do it. Count. It's only because of the output of the type. So I do this, and then I demask this. Okay. So first of all, check the execution plan, what happens here. I can see here in my execution plan, here comes the aggregation. Here, this is my stream aggregate, but look to this. What SQL Server here is doing, it's taking the aggregated values and convert it. And when I look into this, you see that SQL Server is taking the aggregation and making it an integer. And the count big operator does not need this convert implicit. And to be honest, lots of people may say, oh, come on, these few rows here, it's just only 100. It take so much CPU time. Yes, you are right. But think about a data warehouse and you're not counting, let's say the result is not 100 aggregated. I have a big customer, which are 1.5 million aggregated rows. And then you feel the pressure on the CPU. That is the reason. So count big does not need to use a convert implicit for the output of the values. Are there more questions?
Yes, if you can open the chat, there are two more,
Yes.
not on the QA, but on the chat itself.
I see it here. There are no open, or is it the chat?
In the chat itself, there are two more questions.
Let me see. Is it F&A? No, often here's one. Read past hint within the order information. Yeah, good question. Yeah, what do you think about using read past hint within the order information view to avoid locks? Honestly, yes, it is a solution, but the problem is that you will hold the locks then on the resources, maybe longer as you want. I wouldn't do that, to be honest, but yeah, it might be a solution if you know that you will hold the locks then in that case, and that nobody else then can write, for example. And the read pass, by the way, I have to think if there is an X lock on it. So when the update came earlier, then I don't think that it will work because it has to wait for a shared lock in the same way. I need to test it. I need to play around with it. But if you drop me an email, I promise you to answer this by email then. Any more questions? Oh yeah, there's no one. Yay. To get blocking. Do you have scripts to get blocking queries from Query Store? Unfortunately not, no. And Query Store is not my favorite tool. I know many brilliant SQL experts like Aaron Stiletto or Milos Radjovic from Austria. Maybe they have, but unfortunately, no, I don't have. Sorry for that. Oh, there is a big one. Oh, Marcin. Use microservice to see and say it's a all into. Great session. I have a question. In the application, have all about the client and the sales only necessary in sales schema or orders. But the keys are between. You mentioned it. The keys. Sales orders and sales customers via customer ID, using ID to get DOB. May I take this question, Marcin, and because I need to think about this, I want to get DOB from client, joining sales customer to client customer. But create joining sales customer, client customer. Marcin, I take this query, this question from you. Would you please be so kind, drop me an email that I can answer it to you? Yeah, I need to think about it, and I think that it would be like pretty boring when you all seeing me here like this. I know. So let me get this question. Hopefully I can copy it. Yay, copy, Windows Run, Notepad. And I promise you to answer this, Marcin, yeah? Oh, now lots under others coming in. Eins joining, here. Yeah, this is a good question. Why exactly creating foreign key made optimizer skip the employees table? Well, that is really easy to understand from a dedicated point of view. Brent Ozer makes a wonderful session about, it's called Think Like SQL Server or something, or Think Like the Engine. And now, please try to think like the query optimizer. What is the foreign key doing? This is the first question here. So we are referencing, the question is concerning this one here. The first thing, Marcin, yeah, perfectly, yeah, thank you. First thing, when we have a foreign key then SQL Server, the engine, guarantees to you that in the customer orders, in the attribute employee ID, that there will be no value which is not presented in the employees table so far. Then take only or just only concentrate on the join. The output is in the first step here, not interesting in that moment. The join tells me I want to have all customers in a join, means equal, which have placed orders. First condition. Second condition is then, and these orders must have employees which participated from the orders. That means that they have, for example, sold this to me. So SQL Server now knows that there is a relation between the customer orders, and the employees. The view references tables or references columns from the employees. But when we go into the query here, look here, what columns do we need? The first one is coming from dbo.customers. The second one is from dbo.customer orders, but it's only because we want to have the number of orders. That is the reason here. And now think by yourself, if you do not have a foreign key constraint, what do you have to do as a query optimizer to make sure that the following condition is true? I want to see only orders where we have employees in our employee table. And then you see why SQL Server need to touch the employee table, because this one is a condition to SQL Server for the limitation of the rows. When now SQL Server knows with this foreign key constraint that an order cannot have, that there cannot be any order with an employee ID which do not exist in the employees table, for what do you need the employees table then? The employees table will only be touched in two reasons. You have them in the output, 1 point. And the second one is that SQL Server do not trust the relational condition you made with the join query. I hope that this answered your question. And the next one is it possible to share the scripts? Absolutely, yes. So what I will do is I will zip it now and I will send it to the organizers. Maybe they have a possibility to make it available for you. If not, then how can I do this? Yeah, I know how I do this. Not follow me, but have a look to Twitter, have a look to the hashtag of the of this SQL Days here, and I will share the link then with you where you can download it. And then everybody can have it. And if you don't see it, if you don't have Twitter because you don't like social media like I do, then just drop me an email and I will send you the scripts as a zip file. That's very small, it's just only a few kilobytes. Okay, so Martin, I have your email address. Let me do this. 1 second, copy. And then I will send you the answer. Give me 10 to 15 minutes, but then I will answer to you. So I think we are finished. Dziękuję bardzo. Do widzenia till the next year. Bye-bye.